Dr. Gerald Tom, Pavaram Thomas sir, and Jitu, Arun, and all the student paper presenters. First of all, thank you for inviting me for this invited lecture. Actually, I will talk about the role of intellectual property right in economic growth and development. Basically, I'm just trying to make you understand how these enforcement of intellectual property right is important in development macroeconomics. This development macroeconomics, it is a new area of research. So I'm here with this lecture. I'm just trying to introduce you how it is affecting growth, how it is affecting the standard of living of a country. This enforcement of intellectual property right. Let me start with there is a book called Historical Statistics of World Economy. It is written by Madison and published in 2010. Madison is an economic historian, and basically in this book, what he's doing, he is getting per capita income for all the centuries back, all the years back. We have systematic record of per capita income only from 1950 or 1960 for all countries using Penn World Table or any other statistics. But what this Madison doing by this his book is he just calculated world per capita income in each time period in the history. So this is a nice book written by him. And while doing so, what is Madison Angus Madison observed is that per capita income growth, he can calculate per capita income growth, world per capita income growth rate for all the century, for all the years using these, using his techniques, using his scientific techniques. Then he calculated per capita income growth for for the world for all the century, for all the years. Then he observed that from 1 million BC to 80,500, world per capita income was not growing. The world per capita income growth was 0%. That means it is no growing. Suppose take an example, if the world per capita income at 1 million BC is 100, and the same was in 80,500 also. That means the world per capita income at all is not growing. However, we can see some part of the world may be growing, some Rome may be growing in a few centuries, Arab countries were growing in few centuries, Persia was growing in few centuries. But from the entire history of mankind, we can see that this, if you're taking world per capita income, this world per capita income was not growing at all. So however, from 8,500 to 1,750, this growth process started. World started growing, world per capita income started growing very marginally, and this growth rate was below 1%. So it was 0.8%. So the world was growing from 1,500 to 1,750. From 1,750 to present, the world per capita income was growing at 2.5%. So what we can observe from this is if you're taking all the history of humankind, this 250 years is nothing. 250 years or 300 years is nothing. It is very marginal time period. So the sustained growth in income and prosperity is a recent phenomena. So I'm showing you a graph also here. This graph I took from Madison's book.
Sir, hello.
Okay.
Sir, the PPT is not changing.
Oh, it is not changing.
No, sir.
Where it is now, it is sustained growth in income.
It's stuck.
Where it is stuck? The last line, can you read?
Now it's not even visible right now. It's like just the front page. Yeah.
Just a minute. I'm just closing it and then reopening it. I think it will work.
Okay, sir.
Is it changing? Is it running?
No, sir. No.
No. Some technical issues. Let me. What about now? Is it visible?
No, sir. Okay. Wait. 1 second, sir. Okay, sir.
Yes.
Okay, sir.
Okay, that means the sustained growth in income and prosperity is a very recent phenomenon. It started only after 1750. I'm showing one graph also. I don't know whether it could be visible to you or not. Is it visible, one graph? 1 minute. Okay. Here, this I think it is visible.
Okay, sir. It's visible.
Okay. This graph I took from this Madison's book. What it is plotting exactly, in y-axis it is the per capita GDP, and in x-axis it is years. So if you're seeing this, we can understand that this is a per capita income growth rate market here. So only after this 90 after 18th century, this per capita income started growing, and after that we can see a steady growth rate there. So, so the question is here, 1 minute. So the question is here, what triggered this economic growth? What happened after 1700? What happened? Then only after that period only, this per capita income growth rate was world per capita income growth rate started increasing. So what is the trigger factor behind this? So there are a lot of economics like Angus Madison, Douglas C. North, Darren Asimov of Massachusetts Institute, Charles I. Jones of New York University. All these researchers identified that this world per capita income started growing only after the development of intellectual property rights. So the next question coming, how this intellectual property right is affecting per capita income growth rate. So that is what we are trying to understand during this lecture. One famous paper by Romer 1990, it is basically the endogenous growth model of Romer. In endogenous growth model of Romer, for that contribution, he got Nobel Prize also in 2018. What Romer saying, enforcement of intellectual property right motivate researchers and entrepreneurs and scientific community to innovate. Then that innovation is eventually goes to technological growth, and that technological growth is leading to economic growth, and that economic growth is leading to prosperity and development. So it is starting from the enforcement of intellectual property right, then that is motivating innovation, that is motivating people to do innovation, and that innovation is converted to technological growth, and technological growth is going to economic growth and prosperity of countries. So these innovations are the product of ideas. Let me show you how this link is working. First of all, these innovations are the product of ideas. First, a scientific contribution is coming in the brain of a scientist. So that is his idea. So these innovations are the product of these ideas. I think you all know what is rivalrous goods and non-rivalrous goods. Suppose the pen which I am using now is a rivalrous goods because once I am using this pen, no one else can use this pen. The same fashion, the computer I am using, the laptop I am using is also a rivalrous goods. Once I am using this, no one else can use that. So that is excluding all others from the use of that goods. So this is rivalrous. A non-rivalrous also. Let me take the example of Pythagoras theorem. Pythagoras theorem is a good. Then that thing, if I'm using Pythagoras theorem, the same time anyone else can use that Pythagoras theorem. Suppose the plan of a house, once it is written, once it is drawn, anyone can use that. So that is non-rivalrous. So there are rivalrous goods and non-rivalrous goods. Here, its ideas are non-rivalrous goods. That means once it is invented, it can be used by one person or by 1,000 people at no additional cost. So it is a non-excludable good. So once an idea is created, anyone can use that. So up to creation, there will be difficulty. For after creating that, the marginal cost will be very less. Anyone can use that idea without any additional cost. So these ideas are basically leading to innovation. That innovation is basically leading to technological growth, and technological growth is leading to economic growth and prosperity and development. So we know that for each product, there should have a social return as well as there should have a private return. Suppose take example of education. Education has a social return. Education has a private return. Private return means if somebody is educated, he will get more salary. That is his private return. If somebody is educated, he will be a better citizen. He will be a better citizen. He will obey rule, and that is social return. So social return is there. Private return is there. So these ideas have a huge social return than its private return. So the incentive to create new idea depend on the expected profit from it. because it has a lot of social return. People is expecting something from that social return to over their private return. Then only they will start innovating. Then only they will start producing idea. So let me give you an interesting example. You know that in European countries, this winter is very extreme. So it is very cold. Everyone should be ice. So they cannot do their daily activities in winter. So what they will do, they will procure meat and all other goods in summer for their winter. For in every summer, they will prepare meat and all other goods for their winter purpose. So for doing this, they're using spices like cardamom, pepper, many things they are using. But Europe is not cultivating this cardamom, pepper, anything they are not cultivating. So how they are getting this? Initially, they were getting these spices through Arabs. So how these Arabs are getting? Arabs were taking that from our Western Ghats, from our Kerala, from our in the Western Ghats, and they're transporting it to Arabian Peninsula. From this Arabian Peninsula, they're traveling where in that Arabian Peninsula, and they're selling it in the Constantinople. And that time Constantinople, this time it is Istanbul. And they're selling it in Istanbul, and Europeans are getting that spices from there. Using that spices, they are spending their winter. So what happened in the 1453? These due to this collapse of Constantinople, when this Constantinople captured by Arabs, no, this trade route got disturbed. So these Europeans were not getting these spices and all. So they were not getting this trade. So they were not getting this product. So sustaining the winter become very difficult. So this all these governments in UK, then Britain, Holland, Portugal, they started thinking how to get this. They know that it is coming from the place called India, but they don't know the route to India. So that was a problem. So they started navigating across the ocean, in all these Atlantic, Pacific, and all oceans. They know it's coming from eastern side. So they started searching everywhere using this. For that, they started shipping across the world. For this shipping purpose, they know in that time this navigation technology was not that much developed. They should know this latitude. Latitude means it is decided by the angle of a north star in the horizon, and they also have to know this longitude. Longitude is basically a ship's no, east-west direction in the sea. They know only latitude, but they don't know longitude. Because of that, once these Columbus landed in America, he thought he's landed in India, because he was traveling to India to east, and ultimately he landed in America. So he thought he's landed in India, because he don't know his longitude. After departing his journey, you don't know where his direction is. So this unknown longitude create a lot of trouble for this all these shipping people in that time. So what happened? All this government in the UK, all this government in Western Europe offered a lot of money to someone who is inventing this issue, who is inventing this longitude problem, who can invent this. So they also created lot of astronomical observatories across these Western European bands. So they were offered a lot of monetary benefit for someone who is inventing this problem. Ultimately, one guy, he is a poor educated man. His name is John Harrison. John Harrison invented this technique. How he invented, he was a clockmaker. So he was trying to make clock very perfect. That time the watch and clock was not so much developed. So he was trying to accurate more to getting his clock more accurate. And once he traveled from England to New York, then when he's traveling, he took two watches, two clock with him, and one he kept his Greenwich time, and he kept that time there. And next clock he keep on changing its time every day in the noon time when the sun is over his head, sun coming over his head. He just keep on changing to noon. So from that, actually what happened from that invention, these people understand, the scientists understand how far he is from this Greenwich time, related to Greenwich time, how he is from prime meridian, how he is traveling. So for this, he got a lot of monetary benefit from UK. So what is this? Once this is invented, all this shipping purpose was very easy, or they can travel across the sea very easy. So this social return associated with this very high. He will not invent this if he is not giving a monetary compliment for him. So only to motivate him, these governments offered a monetary benefit. Due to that monetary benefit, he can capture some part of the social return from that. So he invented this. The story is written in a nice book, Longitude, the true story of a law genius who solved the greatest scientific problem of his time, published by Walker, New York, written by Sobel. This is available in the internet. You can also download it, and it is very nice book, telling all the story of colonialization and all. So, what is my point here is only because of offering a lot of monetary benefit, this John Harrison invented this. So, since this idea also have a huge social return, someone has to offer some financial benefit for the inventor to innovate something. So that innovation is basically leading to technological growth. According to Romer, that technological growth will lead to economic growth, and that economic growth will lead to prosperity and development. Rather than this, creation of ideas involves large fixed cost and minimum or zero marginal cost. Suppose think about a computer operating system. I'm using this Windows operating system. Think about creating this first copy of this Windows operating system will take a lot of time, lot of effort, lot of resources, lot of financial resources to for these people, many hands should be behind us that creation of this first copy of this computer wise. However, once it is created, we can take a copy of that with a CD. We can just put a CD in a computer and we can just copy that. So this this marginal cost is very minimum, very less. Maybe the cost of a CD, maybe 10 rupees or 20 rupees. But the first unit, for this first unit, the cost is very high. That is, there is a huge fixed cost associated with the creation of this idea. So think about electric bulb. The creation of electric bulb also take a lot of time for this Thomas Alva Edison. He was trying to create to make his first bulb for lot of years. Lot of scientists was working under his lab to create this first bulb. After creating this, he can create another bulb with a minimum cost. So this fixed cost is very high. The situation of COVID vaccine also. COVID vaccine, for creation of this first vaccine of COVID, it was very difficult for all these laboratories. It took a lot of time, lot of resources, lot of R&D expenditure for that. But after creating, if a scientist is getting a COVID vaccine, he can just de-engineer it and he can also make it without any huge cost. So this marginal cost is very low, and however, it have a higher large fixed cost. So we all know that a perfectly competitive market is when average cost is equal to marginal cost and that equal to price. That is efficiency in the market. The market efficiency happen in this point. However, since for the idea, these fixed cost is very high, this average cost will always be higher than its marginal cost. If you go to your basic microeconomic class, you can understand this average cost will be always very high compared. It will be always higher than its marginal cost. However, a market is perfect only when one is selling his goods at its marginal cost. Think about this computer operating system is this Windows is selling only its marginal cost, 10 rupees. Is these innovators will go for this innovation? No, they will not go for that computer or creation of that computer OS. So for creating that computer OS, they should have get some uh, uh, additional price than its marginal cost. Then only that people will innovate. So they should have some legal support to protect of the interest of the R&D entrepreneurs. So what these patent do, patent or intellectual property right do, they are giving a right for that for a product. Only you can produce this product using this idea for a certain years. No one else can produce that. So they can charge price as they wish So that is allowing to pricing above their marginal cost. So due to this enforcement of this patent, enforcement of this intellectual property right, they're getting a pricing opportunity. That pricing opportunity will motivate them to do research. That from that research, it is coming as an innovation. That innovation is leading to economic growth. So that economic growth is leading to a prosperity of countries as well as the development of each nation. So this is a link. I think now you have understand how this link is working. So once the next question comes, is the patent good always? Is the patent good for all countries? Is the protection of intellectual property right is good for all countries, all the people across the world? Is the relationship it is linear? So we know that once a technology is created, it will go to other countries through trade and FTA. FTA means basically that original firm is setting up a factory somewhere in developing countries. So that is FTA and licensing also. They are licensing, the original innovators are licensing some firms in developing countries to use their technology, use their innovation for the production. So that they will get a amount. So technology is transferring happening through trade, foreign direct investment, and licensing. So, given this background, there was always a contradiction between North versus South. North means rich countries in patent literature, and South means developing or underdeveloped countries. What happened? Always these northern countries will do innovation because their patent rights are very strong, their intellectual property rights are very strong. So they will start innovate and they will trade that good to another countries. Think about China. US is Apple. Apple is produced an iPhone, and that iPhone is traded with China people. What these Chinese people do, they will de-engineer, they will dismantle it, and they will de-engineer engineer it, and they will learn how this is created. And from there, they will imitate and they will make their own product in their own brand. So through this trade, technology is leaking to a country, to a less developed country. The same fashion, if a country is setting up a factory here, think about Nike. Nike, you all know, that cloth brand. So Nike has Nike has done so much investment in Bangladesh for this production of Nike product there. So what happened? Even they're employing these Bangladeshi people there. So they will learn how to make this brand quality clothes. Then they will also start producing after retiring from the or after firing out from that company. They will also make the same good. So even this licensing also, some license companies maybe cheat this original company. So through this all way, this technology is diffusing to southern countries. So what these northern rich countries are saying, you are not protecting your intellectual property right. So our technology is leaking to your country. So we are not getting the actual benefit from our innovation. So this will demotivate our scientists and entrepreneurs and who is employed in the research sector. So you have to enforce intellectual property right. So this is what these northern rich countries are saying to southern developing or underdeveloped countries. So what happened? You all know about this Uruguay round of GATT of WTO that come up with a TRIPS. TRIP means trade related aspects of intellectual property rights. So this is an agreement. If a country is agreeing with the TRIPS, he has to protect that country has to protect their intellectual property right. Then only these countries will do trade with that country. This original innovating country will do trade with this non-innovating country. So this was the condition. So for getting trade, for getting foreign product, all the countries should have register this agreement. They have to agree with this agreement. So if someone is agreeing with it, they have to protect their intellectual property right very strong. They have to create legal system, court system, and many infrastructure, legal infrastructure in their country. Then only these countries will do trade. These countries will help them. These countries will set up foreign direct investment there. These countries will give license to that poor countries. So many countries agreed with this. A lot of countries, even these African countries, agreed with this. So there was an issue between this. After all these countries got agreed with this, some issue arose in African countries. That was basically AIDS was spreading like anything in African countries like Zimbabwe, Botswana, Zambia, like countries. Even 15 million people died due to HIV/AIDS virus during 1990 to 1999. So, however, there are a lot of medicines available in the market, but these medicines were produced by, this was patented medicine. Patented medicine was produced by US firms, US and UK firms. They are not ready to give that product to this medicine to African countries with cheap cost. So the price of that medicine was very high because it was their intellectual property right. The patent law allows them to price above its marginal cost. So they were not ready to sell it for a cheap price to African countries. However, at the same time, many people are dying in the Africa. So in international frontier, there was a lot of discussion over this, 10 years discussion over this issue. Why you people are not giving us this medicine for cheap price. At the same time, the countries like India have this generic medicine. Generic medicine is a copy of this original medicine. But these African countries are not allowed to consume that because they are protecting their intellectual property rights. So generic medicines are not allowed in their countries. So these African countries become in trouble. And after a lot of discussion and after dying a lot of people, then these rich countries, rich innovation-driven countries, give the medicine for cheap price. So this took a lot of discussion in international frontier. So what this example shows, intellectual property right protection may not be always good in the context of underdeveloped and developing countries. So if I'm looking to the literature, there are a lot of literature. I'm citing a few here. One is Glaude and Gruben, 1996. What Glaude and Gruben argues, he observed a higher positive magnitude of intellectual property right protection on economic growth for the countries which are more open to the international trade. So it is for a country is more open to trade, the benefit from intellectual property right protection is very high. For other countries also you observe benefit, but the magnitude is very high for open countries, not for closed countries. So another two studies by Thompson and Rashid, 1996 and 1999, they observed intellectual property right promote economic growth only for rich countries, not for poor countries. And another study by Falvey et al. 2006 observed that intellectual property right promote growth for higher and lower income countries, but not for these middle income countries. Another study by Schneider observed that IPR promote innovation only for the developed countries, not for developing countries. A study by Park and Gino in 1997 also observed this intellectual property right promotes economic growth only for the countries above the median of the per capita income distribution. So for this empirical estimation, they took a sample. For the sample above median per capita income is benefiting from intellectual property right protection, and countries below that threshold, below that median per capita income, they're not getting benefit of this intellectual property right. So, observing this literature, this all literature identified a nonlinear impact of IPR on growth. What this nonlinearity means? It is affecting only few set of a countries, few another set it is not affecting. So, all this literature observe this. We know that the link is like this. IPR leads to innovation. IPR leads to more ideas. More ideas leads to innovation, and that innovation is leads to economic growth. But in all the studies mentioned here, what it is doing, they're just regressing. They're doing growth regression by putting a simple IPR variable. So this innovation part is missing there. So they're not incorporating this innovation part. So this will leads to an omitted variable bias all the time. So all this literature has this omitted variable bias. So the endogenous decision of undertaking innovation, which is motivated by better intellectual property right, is not incorporated in the modeling in all this literature. So what we have to do, we have to address here two problems. One is we have to address this omitted variable issue, and second one is we have to identify this non-linearity also. So to do so, I'm just taking endogenous switching regression model proposed by Marginal and Nelson for this purpose. I'm not going to very detail of this modeling. Using this endogenous switching regression model, I can address both of this problem. So in this endogenous sitting regression model, there should have two equations. One equation is basically a selection equation. That selection equation is identifying the relationship between innovation and intellectual property right, and two outcome equation. Using that two outcome equation, we can identify this impact on a certain set of countries, on other certain set of countries. Two groups we can identify. So what I have done, I have just classified countries to two groups based on global competitive index proposed by World Economic Forum. This World Economic Forum, what it is doing, it is classifying countries to three groups. One is innovation-driven countries, second is efficiency-driven countries, third is factor-driven countries. So I kept innovation-driven countries as innovation-driven, and two other groups are non-innovating groups. That means they're not taking any it's not meaning they're not taking any innovation. They are taking innovation, undertaking innovation, but for their main the economy is not led by this innovation. So that is non-innovation driven countries, and another set is innovation driven countries. So we should have one outcome equation for innovation driven country and another outcome equation for non-innovation driven country, and one selection equation also. Using this model, we can estimate this model using two methods. One is two-stage and another is maximum likelihood estimation. I'm not going to into very detail of this, what is maximum likelihood estimation, what is two-stage, and I'm just telling you what result I got. So while estimating this model using these two methods, this two-stage estimation and MLE, what I've done, I have took countries from 2000, took 64 countries from 2007 to 2017 and estimated this model. And I have observed the result using MLE shows enforcement of intellectual property lead to economic growth only for innovation-driven rich countries. So what so far I have overcome these two problems. One is this omitted variable bias due to not incorporating this endogenous decision of undertaking innovation as modeled by Romer into into the econometric specification, and as well at the same time I can identify this non-linearity also. So my result is showing that the enforcement of intellectual property right leads to economic growth only for innovation-driven rich countries, not for all the countries. So I'm not going to very detail. I'm also expecting your presentation. I'm just concluding. What so far we have done, world per capita income started growing only after the development of intellectual property right. So after this development of intellectual property right, it leads to innovation. That innovation leads to economic growth for a certain set of countries. This enforcement of intellectual property right motivated innovation. That motivated economic growth, and that led to prosperity. However, the impact was non-linear across the globe. It was for certain countries, it was positively affecting. For certain group of countries, it was not positively affecting. So, what we have observed in our empirical analysis is it affects economic growth only for rich countries. So I think you all are clear how this intellectual property right works, and how it affecting economic growth. Economic growth is linear? Is that economic growth is same across all countries? We observe that it is not same across all countries. Only rich countries is benefiting from enforcement of intellectual property right. Okay, I have done. Thank you.
Thank you, sir, for that exceedingly beautiful session. Now we will begin our interactive session. The participants are requested to raise their hands and ask questions.
I think all of you understand what I told today.
It is time for the interactive session, so please, everybody ask some questions.
Najib, can I ask a question?
Okay, sir. Okay.
Sir, now we are in a pandemic crisis, and
Yes.
taking vaccines is a crucial thing to fight it.
Yes.
Now we have a tug of war between equity and the rights of the pharmaceuticals researchers.
Yes.
So how can we deal with it? And another question. Recently, we saw an event when we required to import a medicine worth 18 crores for a child in Kerala. What's making that medicine so expensive? If it is a crucially life-saving medicine, can we provide it at a lesser cost? If we get rid of this IPR, or we make it liberalized.
Okay, should I answer?
Yes, please.
Actually, this medicine is very costly only because of its research costs associated with that. This medicine is not produced in a single day. It took a lot of years to produce that medicine. This is why that medicine has become very costly, and plus our tax in our country. So if we are not, if we are forcing that company to give that medicine for low price, what happens? In future, they will not go for another medicine, which is very important for the use of vaccine. After, I think this is a new medicine. After certain years, maybe something around 10 years, this medicine will become very cheap. It is very recently invented medicine, so the price is very high for that. So that is the thing. If you are asking that company to provide it for lesser cost, if you're forcing them, they have to provide. But what's the problem is that they will not go for further innovation in the medical science. So that is the one thing, one answer for, I think that's your answer, serve as an answer. And second one is, and you are also asking about tug of war between these medical companies and government about this selling about the price of these COVID vaccine and all. Actually, what government can do, government has to invest. Government has to invest in vaccines, because if someone is vaccinating, that social return associated with that is very high. So instead of forcing these companies to reduce their price, what government can do, they have to provide, they have to fund it. Then only they will go for another research and analysis research, and they will come up with new technology to fight with another if another pandemic is coming. So that will give a motivation to them. This is my point of view. Okay. Okay, next question. Anyone else can also ask question.
You can also post your questions in the chat box. Anyone can post their questions in the chat box.
Okay.
Good afternoon, sir.
Okay, good afternoon.
Sir, the intellectual property rights was traditionally not used in farming. This position has changed in recent times, and agriculture has been viewed more and more as an industry. Without research and development and clever investment, cannot endure. So, what is the prospect of India as a developing country to boost its current intellectual property policy framework and legislation in order to develop its agricultural technology?
Agricultural technology, okay. Actually, this intellectual property right was not, as you mentioned, it was not very familiar in agriculture. So now our agriculture sector is also changing day by day. We are making it cost effective. This is why new innovations are coming in the agriculture as well, because we know in India more than 40% of the population is dependent on agriculture. This is why we are also, India is also protecting interest of these intellectual property right holders. But the thing is that all these IPR related to agriculture is now that is basically these only these MNCs that took these patents in agriculture sector also. So what government has to do? Government has to promote agricultural research through these institutes such as agricultural university, state, and even in all this technological institution. Also, you can see there are agricultural brand. Even in our institute, IIT Kharagpur also have a good agricultural research area. So what government can do? Government can fund for that for the innovations in agriculture, and the government can fund that. Then only this problem can be solved. Otherwise, even these farmers cannot do that. If government is producing new varieties of seeds, new varieties of saplings, then only that can be used for the use of a relatively high, relatively mass population in the country. So parallel government sector should also strengthen. Okay, any other question?
Sir,
Okay.
sir, how can we promote intellectual property rights for all our traditional and indigenous methods and techniques, be it in production sector, health sector, or any other sector for that sake?
Can you just repeat your question? I'm not getting.
How can we promote intellectual
Okay.
property rights for all our traditional and indigenous method and
Okay.
techniques, be it in production sector, health sector, or any other sector for that
Okay.
sake?
One thing is that under intellectual property rights, as this someone mentioned here, that is basically GI, geographical identification. So if you are registering one product under geographical identification, so only you can sell that product. Suppose like our Aranmula Kannadi. Aranmula Kannadi, it's a traditional thing, and rice in Wayanad, that's Kayamba rice in Wayanad. These all product got some geographical indication. So that is also part of intellectual property right. For this traditional thing, we can have this. We can go for this geographical identification.
Thank you, sir.
Anyone else?
Sir,
Okay.
good afternoon, sir. So my question is related to patent rights.
Okay.
Sir, as you have said, people who have a patent right can exploit the subject matter since they are provided a temporary monopoly. So in case of India, where population is very high and the financial benefit provided by the government is very limited, do this form of patent right can create a positive impact on a developing country like India's investment climate?
This is what is my entire lecture is saying. For the country, this patent right is benefiting only for the people in the rich countries, not for developing and underdeveloped countries. So what the main innovation happening in India? What is the growth? How this growth is coming to India is basically through imitating product of foreign made product. So we are de-engineering it and we are making our own product from that. So if we are enforcing intellectual property right in a country like India and China, that will be harmful for our economy. That is what I'm saying in my lecture also. It is only benefiting only these top cars, only that maybe 10, 20 countries will be benefiting from this enforcement of intellectual property, right? Others will not benefit from that in terms of economic growth.
Thank you very much, sir, for your highly engaging session. I have a question that our R&D expenditure is increasing. India's R&D expenditure is increasing, but R&D as a percentage of GDP of India is falling.
Stagnant. It is stagnant.
What will be the possible reasons for that?
Possible reason, that is a relative concept. That means that it is related to our GDP. Our GDP is also our both our denominator and both are increasing. So this is why, in terms of percentage to GDP, it is somewhat stagnant, or sometimes it is decreasing also. But while we are looking to the numbers, real numbers, it is increasing. That is why GDP is also increasing. We are not our GDP, our R&D expenditure to GDP ratio is not increasing. So the thing is that it is because our GDP is also increasing. Our R&D expenditure is not increasing as our GDP. So it is showing decreasing. I think you got it. It is a relative term. That is right.
Okay, sir. Okay.
Thank you, sir. Due to time constraint, we are coming to the end of the interactive session. It is time for the paper presentation on the role of intellectual property rights in economic growth and development. I kindly request the participant to be ready with their presentations. Let's invite Rudurag MS of First MA Economics to talk about modeling projected increases in urbanization in India. Over to you, Rudu.
Thank you, Chitu. Am I audible?
Yes, continue.
Let me share my screen.
It would be great if the participants could turn off their mic.
Am I audible? Hello? Is the screen visible?
Yes, Rudu.
Okay. So good afternoon to one and all, respected teachers, honorable guests of the day, and all my dear friends. So my paper is titled Modeling Projected Increase in Urbanization in India. As we all know, urbanization in India began to accelerate due to the country's adoption of a mixed economy, which gave rise to the development of the private sector. So our population residing in urban areas in India in 1901, according to 1901 census, was 11.4%. It rose to 28.53% in 2001 and subsequently 34% in 2017, according to World Bank. So in India, out of the total population of 1,210.2 million, as on 1st March 2011, about 377.1 million are in urban areas. So also the net addition of population in urban areas over the last decade is about 9.1 million. That's a huge amount. So this paper tries to present the relation between projected urban population with three factors, that is wages, HDI, and ease of doing business. So, all the data are obtained from secondary sources. Here, wages was taken from Mosby's site, and HDI was taken from Global Data Lab 2019. Ease of doing business was taken from RBI's data, and urban share of population was taken from the report of Technical Group on Population Projection 2020. So these are our data sources. Now, moving on. A multiple regression model was used with the following specifications, and the proposed model was found to be statistically significant. So let me explain the model. So PIUI equal to, so the basic model is PIUI equal to alpha plus beta 0 log wages plus beta 1 SDI plus beta 2 ease of doing business plus UI. So here PIU is the absolute projected increase in urbanization in 2036 from 2011, and LNW, that is the natural log of wage rate, and HDI is, as we know, it is Human Development Index, and EODB is dubbed for ease of doing business, and use the error term. So after fitting the model, we found the following results. The coefficients turned out to be PIUI equal to negative 115.307 plus 14.413 LN wages plus 66.082 HDI and minus 1.843 ease of doing business. So the p-values were 0.003, 0.033, and 0.027 and 0.76 respectively for each of the coefficients. Now, what does this mean? This means that we got our result was like this here. Wages and human development were found to be statistically significant. The former had p-value 0.33 and the later had p-value 0.27. So both these factors, that is low wages and human development, both these were found to be turned out to have the expected sign, that is positive. So they are positively related to our projected increase in urbanization. And so what does this basically mean? This means that when a unique increase in low wages happens, that would lead to 14.41 units, 14.41 units increase in times increase in projected increase in our urbanization. And in case of HDI, a unit increase in HDI would inflate the projected increase in urbanization by 66 units. So on the contrary, ease of doing business was not significant in determining the projected increase in urbanization, since as you can see, the p-value is substantially greater than the table value. So that is not significant in our, so that turned out to be not significant. And what are the inferences? What can we infer from this? So here, what we can basically see is that in the forthcoming decades, increase in urban residents in all of the state in states with higher wage rates and human development. What does this mean? So as we saw, these two factors, that is low wages and HDI, both these were the positive factors. These were significant factors. So any state that has substantially high wages and high HDI would have a drastic urbanization. So that would happen in the forthcoming decades. And yet another thing is that we saw that both the factors, both this HDI and low wages, both are economic factors as well as welfare quota. So the urban population will largely be driven by economic compulsions and welfare quota. So these are the basic inferences that we can make from this model. So what we have to see is that us being from Kerala, this is very much important for us. Kerala being one of the states with high HDI and high wage rates. So we would see a huge urbanization in the forthcoming decades. So that's something else, something to be noted. So this is the very simple model. So these were the results, and this was my inference. I hope that's very much clear. I have also added the sources, references also. So thank you. That's it. Thank you. Hope that was clear.
Najib sir. Najib sir.
Okay.
Yeah, sir, are you making comments now or after the presentation?
We can make comments now, so I will not forget anything. Okay, Ritu, nice effort, good. Actually, you have done a wonderful work. Can you just, once more, can you just show your result?
Yes, sir. Just a second.
Okay. First, you show the model, then we can talk to this. Okay, here, stop here. Okay, actually, what is I stand for? Underscore I stands for state or district?
Yeah, sir. Those are states, depicting the states.
states. Okay,
Yeah.
for all the states in India. Okay, that is good.
Sir,
And
about 22 states turned out to be have the intended data. So it would only it's only applicable to 22 states.
okay, 22 states. And I think you can go for this district level analysis also.
Yes, sir. Yeah.
If you're
Of course, sir.
using
The model, I think the model would be is easily applicable to district levels also if we have the data.
you can get the data of district level GDP or city level GDP you can get, and using that also you can. And I think one more variable should be there in your right hand side. That is basically the current population also matters.
Yes, sir.
Current
So
population also matters. I think you can that will cause an omitted variable bias. You just next time you just put current population also.
population also. Okay, sir.
That will be good. And go one more just go one more step here. Okay, here when you are reporting the result, just show the coefficient you have given and t value.
Okay, sir.
And t value. Then above this t value, you just put stars. If
Okay,
you're
sir.
putting one star, that means it is significant at 10% level. If you're putting two stars, that means it is significant at 5% level. If you're putting one star, that means it is significant at 1% level. So
Okay,
three
sir.
star
Okay.
means more significant, one star is less significant. This is the thing. Rather than giving, I think here, if you're looking for your constant and your ln wage and ln hd, everything it is coming one star.
Yeah, sir.
So that traditionally it means it is significant at 10% level. Everything is significant at 10% level. But showing your p-value, it is significant. This wage is significant only at 5% level.
Yes, sir.
And HDA is also significant at 5% level. For that, you have to put two
Okay, sir.
stars.
Okay, sir.
So to do that, you just put star on this coefficient and report p-value. So that will be better.
Okay, sir. Okay, sir.
Okay, these are one more comment. You just put some papers also in between, according to this paper. This is saying this paper. This is saying like that. Rather than putting in the reference, put
Okay, sir. Okay.
papers here also. Otherwise, it is good paper. Okay, thank you. All the best.
Thank you, sir.
Thank you, Rudu. Thank you, sir. Now, Manu Simon Philippos of First B Economics will talk about Rhine curve of India. Over to you, Manu.
Audible ആണോ?
Audible.
അതെ മല്ലി പറഞ്ഞു.
Good afternoon, respected teachers and my dear friends. I am Manu Simon Philippos, First BA Economics. Today I am going to talk about consulting the rank curve of India. The rank curve is a graph used to illustrate on the economic theory. It was proposed by the Richard Rand in 1996. Thus, the graph suggests that there was a size of government spending at the maximum level of economic growth. The graph is look like a inverted U shape. This was indicating their own decrease overall government spending in the tradition. The rank suggests that there was a optimal level of government spending which maximizing the rate of economic growth. Higher government spending helped to improve economic performance. After exceeding the certain amount of government spending, government taxation decreased economic growth. This graph shows that the rank of India. It found that there was a fiscal deficit 5.7 as per capita growth of maximizing. Thank you. Thank you. Thank you for your valuable time to cooperate.
Can you show your rank curve once more?
Yes, sir.
Just make it big. Okay. Here, this y-axis is your. Hello.
Sir, audible ആണോ?
What is your y-axis and what is your x-axis?
Sir, y-axis growth NSDP യിലും x-axis fiscal deficit.
Fiscal deficit. Okay. Okay, if you are putting some estimation also, then that will be good in future. Suppose
Thank you, sir.
you can do some
Okay,
kind
sir.
of regression, or even there are lot of empirical literature. Even I was searching for that today morning while seeing your topic. In that empirical literature, what they're doing, they're just estimating ranker for different countries, so different subsamples for European countries, for OECD countries like that. So you can also estimate that following that papers. For if you're projecting this rank out, that will be better in the future.
Okay, sir.
Okay. Thank you.
Thank
Manu.
you.
Thank you. Okay.
Thank you, Manu. Thank you, sir. Now, microeconomics of vaccination, a graphical approach, will be presented by Roja Cherian of First MA Economics. Over to you, Roja.
Okay. Am I audible?
Yes, Roja.
Screen കാണാവോ?
കാണാം.
Okay. Respected teachers and my dear friends, good afternoon to all. First of all, my topic is microeconomics of vaccination, a graphical approach. So we know that for any important infectious diseases, the main tool used for eradication or management lies in vaccination against infection. Vaccines save 2 to 3 million lives every year, but bringing vaccines to market involves huge investment, complex science, and contract. But bringing back, so we have no doubts about the private and public benefit from widespread vaccine uptake. So vaccines are the examples of actions with strong positive externalities. Positive externalities mean action that are benefit to others who are not involved in transaction. So because of this monopoly or duopoly position, sellers tend to have a high amount of market power and also have the ability to get higher prices. So before COVID-19 pandemic, few people paid attention to the business models behind vaccines. There are many important fundamental questions about the vaccination market that remain unanswered. The science and economics behind the vaccine industry have evolved significantly since the world's first public situation, that is for smallpox, opened in UK in 1800. The cost and complexity of manufacturing vaccines at scale helps to explain the dominance of four pharmaceutical giants. They are GSK, Sanofi, Merck, and Pfizer, which account for about 85% of the market. The global pharmaceutical market was worth $1.3 trillion in 2019, but vaccines made up just 3% of that, generating around $33 billion of revenue that compared to $142 billion from the cancer drugs. Without taking more time, we can discuss about the economics of vaccination using economic models and theories. To understand easily, we can see it in the form of 6 cases. First one is market solution, second one subsidizing vaccination, third one second best when MSB is unknown, fourth one social cost outweighs social benefit, fifth one selling vaccines at marginal cost preferable over both providing it for free or not selling it at all, sixth one is marginal herd protection benefit or last even at high coverage rate. In this pandemic situation, we are more aware about the importance and the need of the vaccination. But nowadays, our country experiences a shortage of vaccination that is shown in these news reports. But how we solve this problem? So for that, we can discuss the first case, that is market solution. In this figure, the x-axis shows the number of the people who get vaccinated and the y-axis shows the price level. DP is a demand curve. It also represents the marginal private benefit. Up to point QM, there exists the marginal private benefit. But after the point QM, that is the point between the point N and the QM, the percentage of target population plays no private value on the vaccine. It might be if they're concerned about the its side effects or a travel expense to obtain vaccine, or might be indifferent between taking or refusing a vaccine with a zero price. We know that in competitive market, in this case, competitive private market, vaccines sold at the price which equate the marginal cost with the marginal private benefit. Here it happens at the point X. So at that point, with the Q0 people vaccinated and with the market price P0, it maximizes either total net private benefit. And also here we can see that marginal cost is a constant. It is a parallel to x-axis. So we know that marginal social benefit forms when it includes all the benefits of the vaccination. So when marginal social benefit intersect with the marginal cost at point Y, here in this figure, it is marginal cost and the marginal social benefit intersect at point Y. So it is defined as the economically efficient solution from the society standpoint. Nowadays, we are eagerly waiting in front of us various sites to get vaccination as freely. So, because private hospitals provide vaccine at a higher price than the government hospital. So, what will we do for this problem and how we reduce this problem? Its answer is shown in the second case, that is subsidizing vaccination. Case 2 is subsidizing vaccination. So because of indirect protection, however, each additional vaccinated person reduces the risk for the remaining unvaccinated population. So here, to reach the optimal number of vaccine, that is the Q star in the private market, government must offer piggyback subsidy. Piggyback subsidy means subsidy that is used to encourage behavior that have positive effect on others who are not involved. Here, piggyback subsidy is S equal to P0 minus P star. So from lowering the fee to P star, net economic benefit occurs between the area between the point X and point Y, that is shaded area C in the figure. Also, shape and location of the marginal social benefit depend on the epidemiology of disease as well as magnitude of the social benefit. In our society, many people have no capability to take vaccination on higher price. So there is importance of the providing vaccines at the free cost. This is a news report related with that. There is Modi government policy not effective enough. COVID vaccine must be free for all. That is ICMR researchers say. Case C is the second best when MSB, that is marginal social benefit, is unknown. Suppose when the policymakers cannot measure or identify the marginal social benefit, the government might decide that rather than guessing at the optimal subsidy, it will provide vaccine at zero price as a second best solution. So here, number of people who could choose to be vaccinated will be QM, but above the point Q star, that is, we can see that after point Q star, marginal cost is greater than the marginal social benefit. So in that case, social welfare is welfare losses, and that is equal to the shaded area, that is D in the figure. So providing vaccine for free will be a better second best solution than selling them at a market price when area C is greater than the area D. That is when marginal that is a area D area C, that is when marginal social benefit is greater than marginal cost, that is at the portion C. During this pandemic situation, to get more profit, vaccine monopolies, we know that there are many vaccine monopolies in our country. So vaccine monopolies charge higher cost than the actual cost of the vaccine. So its result is it exploits the chance of the people to get vaccination, especially the poor people. Case 4, social cost outweighs social benefit. So in this figure, after the point Q star, we can see that MC is, that is marginal cost is greater than marginal social benefit. So welfare loss occurs, and also it will lead to the failure of the second best vaccination program, that is zero price vaccination program. That is area A plus B plus C is lesser than the area D. So when zero price vaccination program gets failed, a common reaction among people might then be to abandon the use of the vaccine. But there are some people, that is Q0 people, they place high value on vaccine. So they are willing to purchase vaccine at the market price. But if decision makers try to prevent the vaccine from selling at a market price, that is either private or public sectors, Q0 people will lose the opportunity to purchase the vaccine. So we need good health and a better life. So for that, rather than thinking about costs of vaccination, we must take vaccination from available sources because it will save ours and others' life too. Case 5 is selling vaccines at marginal cost preferable over both providing it for free or not selling it at all. So when vaccines are sold at marginal cost, there is a sufficient private demand to reach some critical level of coverage that confers last indirect protection to the remainder of the population. So here, the social loss from providing vaccination for free is greater than the social gain from providing vaccine at a free cost. That is, in this case, area D, that is shaded portion D in the figure, is greater than shaded portion C. That is mentioned that social loss is greater than social gain. Which is providing vaccines at a free cost. That is, if correct subsidy cannot be identified, selling vaccine at the market price would be a better second best solution than providing them for free. So whatever be the cost, we must consider only about the value of it. We must follow this fact in the case of vaccination. As Biden says that getting vaccinated is the most patriotic thing you can do. Case 6, marginal herd protection benefits are large even at a high coverage rate. So when marginal herd protection benefits are large even at a high coverage rate, there is no subsidy that can induce the socially optimal number of people, that is Q0, to be vaccinated. So selling vaccines at a market price is clearly not the preferable second best solution because marginal social benefits are larger than the marginal cost even at the point QM, that is area C1. So there arises a question as whether a program with free vaccine, that is with the QM people vaccinated, is a preferable second best to a program that will provide additional monetary or non-monetary incentive for people to be vaccinated, including compulsory program. So increasing number of vaccinated people between the point QM to the Q star will result social welfare gain. That is, at that point, marginal social benefit is greater than marginal cost. But after the point Q star, we can see that is area after point C2, marginal cost is greater than marginal social benefit. So therefore, inducing higher level of vaccination with incentives would be preferable second best solution when C2 is greater than D, that is when marginal social benefit is greater than marginal cost. And also where social gain is greater than social loss. In that case, only this program is applicable. So there is a universal assumption that free vaccines are always optimal or a preferable second best solution is unwarranted on economic efficiency ground and in some cases may lead to unwise use of scarce health resources. So taking vaccination is essential to save ours and others' life. But knowing which of these situations can apply for a given vaccine in a given location is a empirical question. Thank you.
So according to you, which is the best policy we can adopt now? Using this all cases, which will be the best one?
So I think when a marginal social benefit is greater than marginal cost, we can opt inducing higher level of vaccination with incentives.
So that is case number 3.
Six.
Okay. If you can go for some empirical aspects of this also, then that will be more interesting. So anyway, it is very helpful, very interesting. So these generally our students are not doing any microeconomics modeling. So you have done a good work. Thank you.
Thank you, sir.
Thank you, Roger. Thank you, sir. Up next, Annie Thomas of First MA Economics will talk about fitting Pristine Curve for the state of India. Over to you, Annie.
Thank you, Rudu. Am I audible?
Yes, Annie.
Good afternoon. I am here today to talk to you about Pristine Curve, and I also fitted Pristine Curve for the states of India. So let's get started. Before we moving to our topic, what is Pristine Curve and who introduced it? We might know about these three words, that is income, longevity, and well-being, because these three words are very much connected to our Pristine Curve also. Better health and life expectancy are an indicator of a good quality of life. The most obvious explanation behind the link between life expectancy and income is the impact of food supply on morality. Higher income leads to better access to housing, education, medical services, and other items tend to improve health. Therefore, aggregate income can be taken as a good indicator of life expectancy. You can be more familiar with this in the coming slides. We're moving on. The Pristine Curve was named after its founder, S.H. Pristine, Samuel Holtz Pristine, in 1975. He is an American demographer and sociologist, and he is also one of the leading demographers in the United States. The Pristine's study analyzing the data in three different decades, the 1990s, 1930s, and 1960s. So basically, what is Pristine Curve? The Pristine Curve is an empirical cross-sectional relationship between life expectancy and real per capita income. In 1975, the relationship was investigated by Samuel Pristine in an article that was republished in 2007 with the commentaries by the author and other scholars. In this influential study, the life expectancy at birth of countries around the world was found to be related to their gross national income per capita, a quantity that is frequently used as a maker of national wealth, living standards, and economic development. Pristine showed that the cross-sectional relationship between life expectancy and real per capita national income across countries can be accurately described by the so-called Pristine curve, with rapid increase in life expectancy in countries with lower income and slower increase in countries with higher incomes. Over time, the Pristine curve tends to shift upwards, reflecting improvements in life expectancy independent of national income. So basically, the Pristine curve shows the empirical cross-sectional relationship between life expectancy and real per capita income, and it demonstrates the richer countries having higher life expectancy than poor countries. However, the link between income and life expectancy flattens out. That is, there are diminishing returns to income in terms of life expectancy. This is because recently life expectancy has increased in most countries independently of changes in income. Betterment in health facilities, education, technology, and vaccination, and other healthcare services increase the life expectancy in poor countries also, independently of changes in income. Diminishing returns to income in terms of life expectancy means our income increases, life expectancy increases at a certain point. After that point, it's saturated or flattens. That can be more clear in our coming slides. Next, we're moving to our model that I fitted Pristine curve for the states of India. For this analysis, we took data from secondary sources for both variables. For life expectancy, we took data for the year 2010 to 2020. And for the NSDP data, we took data for the year 2019 to 2020. SPSS was used for the model fitting analysis. Here, in the next slide, as we can see in this slide, Pristine curve for the states of India. In the x-axis, the Pristine curve shows the NSDP per capita, and in the y-axis, the Pristine curve shows life expectancy at birth. The equation of our model is yi equals beta 1 plus beta 2 1 by xi plus ui. Yi is life expectancy, that is our dependent variable, and xi is NSDP per capita, that is our independent variable. Here, the ui error term represents the factors affecting the life expectancy other than NSDP per capita. Actually, you can see our Pristine curve looks like a short-run production function, similar to short-run production function. That means the curve increasing at a certain point, then it's flattens or saturated. You can clearly identify this in this figure. At a certain point, it's saturated. For getting this kind of graph, we use inverse model in regression analysis. In the next slide, we can see the result of the model. Yi is equal to 72.165. That is our limiting point where the curve becomes saturated or flattens. So the curve for the current life expectancy in India is 72 according to GDP per capita. Here the P less than 0.01 is the significance level. And in our model, we get the significance level 0.008. That is less than our 0.01. So we can accept the hypothesis. So in the graph, we plotted different states in India. Different states in India. Here there are 21 states in the graph. The states in the bottom left of the curve has lesser life expectancy, and the states in the top right has high life expectancy. We can figure out the position of the Kerala from this graph. Kerala is in the position of top right. So Kerala having a high life expectancy compared to other states in India. So in conclusion, we can say that India has a high life expectancy and the variable income significantly affect the life expectancy at a certain limit only. In our model, the limiting point is 72. After that point, the link between life expectancy and per capita income is flattens out because there are so many other factors also affect the life expectancy of a country. As I said at the beginning, better education, technology, vaccination, and other exogenous factors improves health. That is, if we look at the world today, however, the relationship between income and life expectancy begins to weaken once income reaches the certain level. This is well illustrated in the developed countries example. In 2012, a child born in Hong Kong could expect to live for 83.6 years, the longest in the world. The next countries in the longevity list were Italy, Switzerland, Japan, and France, all of which have a rather significant variation in income. One of the biggest outliers among the developed countries was the US, high per capita GDP, but rather low life expectancy. From this, we can clearly say that higher income does not always lead to higher life expectancy. So that brings me to the end of my presentation. I believe that you got an idea about the Pristine Curve and the model which I fitted. Thank you for your patient listening.
Okay, nice presentation. Congrats. How can you accommodate even Kerala model of development we were discussing so far in many papers and all. Actually, what was this Kerala model? We have a higher life expectancy ratio and lower income in the initial time of Kerala model, something around 90-80. How can you accommodate that here in this Pristine Curve?
Sir, can you explain once more?
We were talking about Kerala model of development for a long time in our economic history. So, what was one advantage of Kerala model of development was Kerala have a higher life expectancy with low income. But nowadays it is changing. Kerala have both higher income and both higher life expectancy. How you can incorporate this trend? That means higher life expectancy with low income in this Western context. How can we incorporate that?
Sir, basically,
Is there an outlier, Kerala? Yeah.
Sir, in the case of India, Kerala has high life expectancy, and also Kerala has a good amount of GDP per capita also.
Okay. Actually, what was the condition in 1980s and 1970s? The states such as Kerala has less income and higher higher life expectancy. So that was Kerala model of development. That time. What I'm asking, can you accommodate this into your presentation, or if the one thing you can do is you can now you have done this for 2020, yes?
Yeah.
You can do this for many years, something from you can start from 1960, 70, 80, like that. For many years you can include.
Okay.
So that will be better. And another question is that Pristine Curve is valid for 2009 also in international level. Have you checked it?
No, sir. No, sir.
Okay. The data is available in Penwell table. Penwell table and World Economic Forum. You can get the data from the World Development Index of World Bank. There you will get life expectancy and this income per capita, purchasing power parity adjusted per capita income. Using that, you can check whether that data is available up to 2019. Then using that data set, you can also check whether this Pristine is valid now. So that is one thing. And one more thing, using this NSSO data, NSSO has a huge data sources for different years. So different rounds of NSSO, you will get the average income, per capita income you will get from there, and you can calculate this life expectancy also. If you are trying to extend this work to a paper, then it is better to take data from NSSO, extract data from NSSO dataset, and you can do modeling better in sub state level also. You can do sub district level or NSSO unit level, anything you can do in the future. Okay, that's all.